Problem 2, internal rate of return lessons. A utility company is considering the purchase of one new screw conveyor from one of the two manufacturers for its wastewater treatment plant. The estimates are manufacturer 1 and 2. The first cost, initial cost, $8,000 to $13,000. Annual disbursement, $3,500, and manufacturer 2, $1,600. Salvage values for manufacturer 1, 0. Manufacturer 2 at the end of year 5, 2,000. The useful life for manufacturer 1, 10 years, and 2, 5 years. Using IRR, determine which manufacturer should be selected if so mark is 15% per year. 15%. So the question asks explicitly using IRR method. So we have to use that method. No other choice. And we have involved compare multiple alternatives. In this case, 2 alternatives: manufacturer 1, manufacturer 2. So that we go to the node selection from multiple alternative with our IRR. That in the previous lesson video, the procedure, we have 3 steps, and in this case only 2 alternatives. For the problem 2, I focus on the step 3. So one by one, calculate the incremental value of each challenger with the best alternative found so far. So only we have 2 alternatives. So one by one, compare those 2 alternatives with incremental value. And then when we go to problem 3, we applied the whole procedure from step 1, step 2, and step 3. Now we just fabulous step 3 for this problem. So let's do that here. And of course, this one, I know, focus on step 3 of the IRR analysis. So let's make a note here. Problem 2, just only focus on step 3, one by one, calculation of incremental values of the IRR analysis. So keep that in mind. So with that, we always start with draw the cash flow diagram. And in this case, as you can see, different life for manufacturer 1 equipment, and 2, 10 years and 5 years. So as you can see that we have to use and the problem don't say the planning horizon, so we have to use approach 1, LCM, least common multiple. So that one, we have LCM of 10 and 5, and that equal to 10 years. Then we draw the cash flow for each of them. Manufacturer 1, 8,000, and manufacturer 2, 13,000. So as you can see, in terms of the ranking for other alternative by increasing initial investment, so that increasing, so that 8,000 and 13,000. So you should go from 8 to 13. So in that case, you can see that manufacturer 1, it become a defender. And manufacturer 2 is challenger. It always you start with the least initial cost. No one want to invest more. If you have the same benefit, then put the less money in. So that way the defender. The challenger have to justify. It's better to put more money to get more benefit. Then you go with that. Otherwise you go with defender. So that way we have that. So with that, we can draw the cash flow diagram for manufacturer 1. And that I say defender. and that is here for 10 years, as you already know. 10 years 0, 1 to 10. Initial cost is 8,000. Annual cost 3,500 every year for 10 years. So a 3,500 per year. Similarly, we have manufacturer 2. And that challenger. And draw the diagram, cash flow diagram with 0, 1, 5, 6, and 10. Initial cost 13,000. And then annual operating cost 1,600. $1.6 okay per year. And because that is the LCM, least common multiple is 10 years, we assume we reinvest the same equipment for the next 5 years, so that at the end of year 5 you get the service value. No service value for manufacturer 1 equipment, but 2,000 at the end of year 5. So you have here 2,000, and we have to reinvest a new equipment 13,000, and you assume we have the same operating cost 1.6K per year. And at the end of year 10, we service value again 2,000, something we familiar with so far. So with that, we go to step 3, one by one, calculate incremental value of each challenger with the best alternative found so far. What does that mean, incremental? When you say incremental, something we have subtract, difference. Make sense? So in this case, we want whether it's justified to put more money from 8,000 jump to 13,000. Is that justifiable? So that one, we have the cash flow diagram of manufacturer 2 subtract manufacturer 1. So that why we put here incremental. And by incremental, we get 2 minus 1. 2 minus 1. So get whether I should put more money. It means I add extra $5,000, jump from 8,000 to 13,000. Should I do that? Whether I get more benefit. And that here. So just subtract one by one in there. So you have here 5 and you have 10. 5, 0. At 0, negative 13, subtract negative 8, so you get 5 going down. 5,000. And then negative 1,600 minus negative 3,500, so it becomes positive 1,900. 1,900. 1900. And that 1900 per year. Negative 1600 minus 3500. Minus of minus 3500. So you have positive number. And then you have at year 5, in the manufacturer 2, you have negative 13 plus 3, so you plus 2000, so it means you have 11,000 at year 5, nothing at manufacturer 1, so you have 11,000 going down at year 5, 11,000. At year 10, you have at manufacturer 2, we have positive 2,000 minus 0 at year 10, so here it had 2,000. And with that, we want to see, now I put extra 5,000. If I jump from manufacturer 1 to manufacturer 2, then I get the benefit. I save the operating costs from 3,500 go down to 1,600. It means I could have saved 1,900,000 per year. But I have to put more money at year 5, 11,000, and I got the service value 2,000 at year 10. And with that, we can be able to find out that incremental justifiable. So with that, we can find out the NPV for incremental cash flow, 2 minus 1 for I star, and that is equal to negative 5,000. By now, you know what we going to do, plus A, 1.9K, factor P over A, because same amount over 10 years, I star, 10 years, minus 11K at year 5, we have P over F, I star, one single amount at year 5, and then we have 2,000 plus 2,000 P over F I star at year 10. And that have to be equal to 0. And now solve with calculator. Use calculator. And now you should try it. Not only should, but I should say you have to try it. You calculator to make sure you can be able to do this problem with your calculator. So with that, we have to replace the factor in here. Go back to P over F, P over I that we talked earlier in problem 1, and then we can plug in here. So that we have that NPV 2 minus 1, so incremental I star equal to negative 5K plus 1.9K, and that equation P over A factor is 1 plus I power 10 minus 1 I 1 plus I power 10. Negative 11K, that factor equal to 1 plus I power 5 plus 2,000, that factor is 1 plus I power 10, and that equal to 0. So with your calculator, you can solve for I, and that you have IRR Actually, I make that equation numerically correct, and that is equal to 12.7%. You can try with your calculator. And we have to compare with math. With the I, you go back to the first lesson video. IRR greater than MA, financial viable. MA in this problem is what? Go down to this problem. The MA is 15% compared to yes. So this one, as you can see, it's less than MA, minimum attractive rate of return, 15% per year. So what does that mean? This incremental values, incremental investment, jump from 1 to 2 is not financially viable. Okay, so what does that mean? In less than money, then you choose the one with the less money because it's not viable to put more money. Mean that not viable to invest extra 5,000 to go from 8,000 to 13,000. So what does that mean? It means that defender win. So choose the least initial cost, manufacturer 1. So that should be the answer. Choose manufacturer 1. If you get the answer IRR, for example, 16% and greater than 15%, then it's viable to put more money because you save more, and that will be challenger win. So it always compare with MA to go with defender or challenger. In the next problem, problem 3, we go all 3 steps in IRR analysis.